Now, a hexagonal lamina of size 30 mm is resting on HP with one of its corners on VP, and its surface inclined at an angle of 30 degree with VP, and the diagonal passing through that corner which is in VP appears to be inclined at 45 degrees to HP. Draw the projections of the lamina. So here a hexagonal lamina of size 30 mm is resting on HP with one of its corners on VP. Since it is resting on one of its corners, so it has to rest on corner on HP, corner on VP, and a side is resting on HP. So you can see that side is resting on HP. So here what we have done is all the sides are resting on VP. So obviously it is parallel to VP, so I am getting the true shape. Since the side is resting on HP, I am keeping that side on horizontal plane. Okay, but here we have considered the distance is in front of VP. So we have taken the deliberately that in front of VP by some distance. That is because if I write it here itself, then you will not be able to identify the front view and the top view easily. So in order to make us to understand that it is parallel to VP, so the condition has to be parallel. So we can see the parallel to VP. So we can see a true shape in VP, and since one of the side is resting on HP, so this side is resting on HP. But when it goes to the second position, then we will going to take the condition that one of the corners are resting on VP. So here, so how to draw this? So first what you need to draw is not to draw an XY line first. Why? Because we have to see that the side is resting on HP. So one way is you draw a first 30 mm line and then draw 60 degree here and draw 60 degree here and construct the hexagon. That is one way. So the other way is first you draw a 60 mm line, because it is 2 times the side. It is 2 times the side means it is 2 times the 30 mm. So you are going to get a diameter of 60. Consider the center. You draw a circle of radius 30, and since it is resting on corner, so you take the horizontal diameter. You throw a dash and through this point. You cut an arc of radius 30 on this side of the arc, and also on this side. And similarly from D dash you cut an arc on this side and also on this side. You will get 6 points, that is A dash and D dash is already got, and then you will get B dash, C dash and E dash, F dash. Then all the 6 points you join, you will go to get a hexagon. And then from F dash you draw a XY line, and from E dash also you draw an XY line. So this is how also you can be able to construct. Next is one of its corners on VP, and the surface is inclined at an angle of 30 degree with VP. So now you can see the surface is inclined at 30 degrees to VP. So still that side is resting on HP, and one of this entire surface is inclined at 30 degrees to VP, but still one side is resting on HP. Then still that surface is perpendicular to VP. So you are getting a line in the top view. So you are getting a line in top view. So one of the corners is resting on VP. So I have satisfied the condition here. Here A I have kept in front of VP, but here A is resting on VP. So it is satisfying the condition. So once the surface is inclined, obviously the diagonal we will go to get, the diagonal will be in apparent length. You can see here the diagonal in apparent length. And here the diagonal will going to be true length. AD is the diagonal which is in true length. That is because A dash D dash is parallel to HP. So I am getting the true length in here, true length in HP. Since AD is inclined to VP, so I am getting the apparent length. What is the length of the apparent length? The apparent length is always less than the true length of the line. Next, the diagonal passing through that corner which is in VP. So which is the diagonal passing through the corner? The diagonal is A dash D dash, which is passing through the corner is A, which is in VP. So A is the one which is in VP. D is in front of VP. Even though the diagonal is also AD, D is also we can be able to rest. But now the diagonal is A is resting on VP. So appears to be. Appears means it is always the apparent inclination. And see the second position front view where the diagonal will be in true length or in apparent length. Since the diagonal is inclined to VP, so I am getting the apparent length here. And the inclination given here is the apparent inclination. So since I have to reproduce the same sketch in the third position, first you draw a line inclined at 45 degrees, which is the apparent inclination, and the length here is what we have is the apparent length. So you transfer it directly on this to get AD. Then once you get that, measure the length from A dash to this point, and from A dash you cut an arc on that 45-degree line, and then since this line is perpendicular to this, so by using a protractor you measure an angle of 90 degree with respect to this inclined line, and then you draw a perpendicular line to this inclined line and measure the length from this point to B dash. From this point you cut an arc to get the B dash, and similarly from this point on this side to get the point F dash. Similarly measure the length from A dash to this point, and from A dash you cut an arc on this. Since this line is also perpendicular to this A dash D dash line, similarly from this point by using the protractor measure an angle of 90 degree with respect to this inclined line A dash D dash, and then from this point you measure the length of this, which is from this point to C dash. From this point you cut an arc on this, and also from this point you cut an arc on this to get the point A dash. So join A dash, B dash, C dash, D dash, E dash and F dash to complete the sketch. So this is how we are reproducing the second position front view. And then to get the top view, draw a vertical projector from A dash to get the horizontal projector from A to get this point. Similarly, draw a vertical projector from B dash and F dash, and draw a horizontal projector from B and F to get these 2 points BF. Similarly, draw a vertical projector from C dash and A dash, and draw a horizontal projection from CA to get the point CA. Draw a vertical projector from D dash and draw a horizontal projector from D to get this point, and then this complete the sketch. So this is how we will be able to get the 3D position and complete the sketch. And similarly you can see here in the 3D view also, you can see A is resting on VP, and this top view and this top view will almost match, and this one will be matching with this particular thing. So this is the diagonal AD, A dash D dash, which is inclined at an angle of 45 degrees, which is the apparent inclination, because he says it is RTS. So how do I know that my problem is right? The diagonal passing through the corner on which the lamina rests makes an angle of, appears to be inclined at 45 degrees to HP, and then the surface makes an angle of 30 degrees to VP, and one of the sides is resting on HP, and the side is resting on, one of the corners is resting on VP, and this is a side of 30 mm. So this is how we will be able to analyze the problem, and hence my problem is right. Thank you.